So this is 9.1. We're going to solve systems of equations. You guys have seen systems of equations in Algebra 1. This first lesson, we're going to solve specifically using substitution. Do we remember what the other method was called? It was substitution and what? Yeah, right, elimination. So we're going to do elimination tomorrow. So this first lesson is just going to be solving using substitution. What does it mean to substitute something, just in general? Not even in math, but to substitute means what? Yeah, like you're going to swap it out with something else, right? So you're going to replace it with something that is the same thing, right? So that's essentially what we're doing here. When you're solving using substitution, you want one variable by itself. So you want either an x equals something or you want a y equals something. Whatever you get from that is what you're going to plug into the second equation. In place of whatever x or y you just solved for, you're going to solve, get an answer for x or y, and then plug it back into the equation to find the other variable. Okay, so let's solve using substitution. Again, the very first thing that we should try to get, right? So the very first thing is either an x equals something or a y equals something, right? You don't need both, you just need one or the other. Do we see that now? Just x equals something, just y equals something? No, right? So we want to try to rearrange one of our equations to get x equals or y equals. It doesn't really matter which one you do. Let's just say I'm going to rearrange the second equation. How can I, with the second equation, get either x or y by itself? What's one thing that we could do? Add the y, right? I think I heard it over there, right? Add the y. I just want x or y by itself. Let's add y to both sides. And then what does that give us? That gives us x equals 2 plus y. Do we see now that we have x equals something? All right, good, right? So this is our equation. Now what we do is we take this and we plug it into the first equation. All right, so if this is x equals something, the x that we see in this equation is right here. So this is where we're going to plug in 2 plus y. Someone get that for me? So we're going to replace that x that I circled with 2 plus y. So this is going to be 2 plus y equals 4. Right, so what I just highlighted, the x and the 2 plus y are equivalent. Are we fine with that? All right, and then we just combine like terms. All right, how does this left side of the equation simplify? Not y squared. Y plus y is how many y's? 2, right? So it's going to be 2 plus 2y equals 4. All right, and then from here, it's just basic Algebra 1. Solve for y, we can subtract 2 on both sides. And then we're going to get 2y equals 2. So what do we get for y? Nice, right? So we get y equals 1. So that's one part of our answer. Are we fine with how we got y? Good, right? So then that's one part of our answer. And then what we do with that number, we plug it back into our substituted equation, and then we solve for x, right? So now let's replace this y right here with a 1, right? Because we just found that y equals 1. All right, so then we're going to get x equals, instead of 2 plus y, it's going to be 2 plus 1, so what is x? 3, right? So we get x equals 3, y equals 1. Does anyone remember how we write our final answer in these kinds of problems? Yeah, right? So it's going to look something like this. It's always an ordered pair x comma y. So that means I'm going to have a 3 comma 1. It's always a point. So our answer is 3 comma 1. It needs to look like that. You can't just write x equals something, y equals something. It needs to look just like that. Just because these on a graph, like let's say we were to graph these, they would look like a line. You'd probably get a line something like that, and then a line something like that, right? And then if you have your XY plane, it would probably be a point right there, right? So that's visually what this would look like. Obviously, it wouldn't look anything like that. It would look like a point passing through 3, 1. But visually speaking, we have this as our solution of a system of equations. Typically, it's a line and a line, but towards the end of this lesson, we're going to do a line with other things. All right? Good with this first one? Alrighty, good. So let's try the next one. Let's try the exact same thing. We want to solve this one using substitution. So again, the very first thing, we want what specifically? Good, so I want either x equals or y equals something. Do I see that already without changing anything? No, so you do need to change one of your equations to get x equals or y equals. Which one looks easier to change? The first one, right? We just have a plain x and a plain y, right? So let's say I want to get the x by itself. How would I do that? Yeah, right? Add the y to both sides, right? So then we get x equals y. All right, so I just changed the first equation. That means you want to take this and plug it into the second equation. All right, so let's replace the x that we see in the second equation with a y. All right, because that is our substitution. So this is going to be 5y minus 3y equals 6. All right, what can we do now? Good, right? So then this is going to get us 2y equals 6, and then what do we get for y? Nice, so we get y equals 3. What should I do with that number now? Plug it into the original, right? Whatever we just substituted. So replacing that y with a 3, we get x equals what? 3, right? Super easy. And then how would I write my final answer? Nice, 3, 3 as an ordered pair. All right, so let me split this up. All right, so that's the basics of this lesson. All right, we okay with that? Especially those of you that are taking the SAT, sometimes you'll have a real world scenario and you're going to have to set up a system of equations and then solve whatever you just wrote. All right, I would always annotate whatever it is that the problem is asking. So let's do this one together, right? So this one says a total of $12,000 is invested in 2 funds. So that's some clue to you, right? You're going to have to do something with that 2 funds. We can call these funds X and Y. So X is one of the funds, and Y is the other fund. And the total amount that we invested is $12,000. I'm going to write a simple equation. X dollars, right, plus Y dollars is going to equal $12,000. Right, so what does this equation that I just wrote represent? You shouldn't have to think much. It's in the problem, right? What does that represent? Yeah, right, the total amount, what? That you invested. So I'm going to say that this first equation represents the amount invested. So we already have one equation. All right, let's finish reading the problem. It says that these 2 funds pay 5% and 3% simple interest. The total annual interest is $500, right? So is $500, I know that means something is going to equal 500. All right, and what exactly equals 500 is the interest, right? The amount of interest that you get. But we also have that 5% and 3% represent the simple interest in the 2 funds. Anytime you have a percent, you're always going to write it as a decimal. So what's 5% as a decimal? 0.05. So I'm going to say 0.05 times one of my 2 funds, X, is the amount of interest in that fund. And then the other one, 3%, I'm going to write as 0.03 times y, right? Y is the second fund. All right, so what does this blue equation represent? If the red one represents the amount that you invested, what does the blue one represent? You're right, so this is the amount of interest. So anytime you're doing these problems, you always want to make sure that your equations make sense, right? The first equation should strictly be the amount that you invested. And then the second equation should strictly be the amount of interest that you earn. All right, so that was probably the hardest part of this problem, is setting up the equation, right? You're gonna have to know how to do that. The next hardest thing would be to actually solve it. All right, we don't really like the decimals here. Does anyone remember how you can get rid of decimals? Okay, well, if I move this one, you can very simply just move it over twice. And then if you do that for one of them, you can do that for the rest of them, right? So let's change the decimal for the rest of them, right? So because 500 is a whole number, it's going to be 1, 2 over. That means you're just going to add 2 zeros. So just a little tip for you guys, right? So this is just a simple way of how you can get rid of decimals, let's say in a given problem. If you have decimals and you don't like them, that's how you can get rid of them. And then so that's going to make this equation 5x plus 3y equals 50,000. All right, does that seem a little bit better than the decimals? Yeah, right? Now it's time to actually solve it, all right? Let's actually solve this equation. You can use any method really, substitution or elimination. This is a lesson on substitution, so I'll do it that way. Let's look at our first equation. Let's try to substitute something there. Is there something that we can get by itself, x or y? Sure, we can try to get x or y by itself, right? If we want to get y by itself, how would I do that? Good, minus x on both sides. So then the equation that you're substituting is y equals 12,000 minus x. So then this is what we're going to substitute. Now, since this is an equation of y, I'm going to replace that wherever I see the y. I see a y right there. So that means I'm going to take this and plug it into that y. And then you're solving that equation. So this is going to be 5x plus 3 times, instead of y, it's going to be 12,000 minus x equals 50,000. And then you're just going to distribute the 3 and solve for x. So distribute 3. This is going to get you 5x plus, do we know what 3 times 12,000 is? 36,000, right? What's 3 times 12? 36, right? And then there's 3 zeros, so 36,000, right? And then minus 3 times x is just minus 3x equals 50,000. Whoa, where'd it go? Hold on. Okay, so then we can combine like terms. The 5x and the 3x is going to get you a 2x. And we can subtract 36,000 to both sides. And then this ends up getting you 14,000. Very simply, we can divide by 2, so what do we get for x? 7,000, right? 14 times 2, or 14 divided by 2 is 7, and there's 3 zeros. So I get x is 7,000, right? What does that mean? That means the account that invested, 5% simple interest? You invested 7,000 in that fund. All right, how do we find the other one? Just plug it back in, right, for this x. So then we're going to get y equals 12,000 minus 7,000. All right, what's 12,000 minus 7,000? 5,000, right? So you invested $5,000 in the account that gets you the 3% interest. Right, so it might be a little bit tedious, shouldn't be that difficult, I would hope. And you're not always going to have money problems, right? Sometimes, depending on the context, it's, I don't know, sometimes it's adult tickets versus child tickets. Sometimes you're selling tickets, or you're selling food, something like that. You need to find the value of each item, that sort of thing. Right, so there's plenty of context that you could use these in, but this is just one of them. And because that kind of took a long time, this next one we're just going to set up, but we're not going to solve it. So let's kind of do it the same way, right? So we have a total of 25,000 invested in 2 funds. So how can I write that equation? 25,000 invested in 2 funds, right? Think about what we did in the previous. Nice. So x plus y equals 25,000. So that's our first equation, and then we have 2 funds paying 6.5% and 8.5% interest, and we have the total amount of interest is 2,000. How can I represent that? 0.065. We can say that that's times one of our funds, so x, plus what would our other one be? 0.085 times y. Good is going to get us $2,000. All right, so this is how we can set up a system like that. A lot of times that's the hardest part. All right, are you okay with that? So I'm just going to leave it there. We're not going to solve it. Okay, nonlinear systems. This is a line maybe with another type of equation. So this is if your system of equation has an exponent. So for example, let's say I had a line, right? We know what a line looks like. It looks something like that with a parabola. Do you remember what that shape is? A U, right? So it's going to look something like that. Right? And we can see that now there's not only one solution, but there's how many in this image? 2, right? There's another point where it crosses. Right, so this is visually what this might look like. There's plenty of other cases, like maybe there's no solution, like maybe you get a parabola and then a line, something like that, that they never touch. Or maybe you get a parabola facing downwards, and maybe it just touches at one point. Right, maybe it touches just at one point, and you have one solution. All right, plenty of different cases, and if you get really deep into it, sometimes there's like a circle with, I don't know, a parabola, something like that. But we're only really going to do a simple case of a line with a quadratic equation, right? Well, just for the sake of this class, we'll kind of keep it simple, right? But this is visually speaking what a nonlinear system would look like. A strictly linear system would just be a line with another line. A line and a line. So this is a strictly linear system. This is what you guys did in Algebra 1. All right, but nonlinear systems could have any other type of equation. All right, but let's solve them. When we get to number 6, I think your guys' number 6 is different from mine. Just when we get there, just change it. But let's look at this one. Let's still do it using substitution. Anytime you're doing these, you always want to take the simpler equation and get that number by itself first, right? So which one looks simpler, the first or the second one? Definitely the second one. And you want to get whatever looks like it would be easier to get by itself, right? So if I have a 2x and a y, I would say y looks a little bit simpler. So let's try to get that by itself. How can I get the y by itself? Sure, we can subtract 2x on both sides. And then we get negative y is negative 1 minus 2x. Now this is negative y. How do we just get y? Sure, right? Let's divide by negative 1. So then we get y equals 1 plus 2x. All right, so that's our first equation. Well, that's our substituted equation, sorry, of the second one. All right, where should I put that now? All right, put it where you see the y in the first equation. And we see a y right there. So then this is going to become a 3x squared plus 4x minus, instead of y, we're going to put a 1 minus 2x equal, or 1 plus 2x, sorry, equals 7. All right, we want to make this look a little bit simpler. How can we do that? All right, let's take that negative outside the parentheses. Let's distribute it just to get rid of the parentheses. And then we end up with a 3x squared plus 4x minus 1 minus 2x equals 7. All right, let's combine like terms now. 4x minus 2x. What does that get you? 2x. So I get 3x squared plus 2x minus 1 equals 7. And now this is a quadratic equation. What do we want these to equal? In order to solve it, what should we do? I would have moved the 1. Move the 7, right? So I would subtract 7 on both sides. Right, so we're going back to things that we did the very first semester of this class. All right, so we get an equation that looks something like this. How would we try to solve that? Yeah, right, we would try to factor it. Did we forget how to factor? Maybe, right? But let's refresh, right? We need factors of negative 24 that add to positive 2, right? What do we get from that? Good, 6 and negative 4, right? So this is going to become x plus 6 and x minus 4. All right, this is one of our special cases. What should I do with those numbers now? Good, right? There's a 3 in front, so we need to divide these by 3. 6 divided by 3, does that get you anything? Good, 2. So we get x plus 2. 4 divided by 3, does that get you anything? No, so let's move the 3. Good. So we get 3x minus 4 equals 0. Good, now we set each of these factors equal to 0. What do we get for one of our answers? Negative 2. What do we get for our other one? 4 over 3. So we get two answers here. One of them is going to have an ordered pair of negative 2 comma something. The other one is going to have an answer of 4/3 comma something, right? So you're going to have to plug both of these in. But you always want to plug it into the simpler equation, right? Look back at the original. Which one did we say was simpler, the first or the second? Definitely the second one, right? So let's plug it into this that we substituted in, right? So y equals 1 plus 2x. Let's replace the x with a 2, right? So let's start with that one. So y equals 1 plus 2 times negative 2, right? And then what does that get you? 1 minus 4, so what does that get you? Negative 3, right? Good, right? So that means with the negative 2, our answer is going to be negative 2 comma negative 3. All right, good with that one? And then we're going to do the exact same thing with 4/3. Right, so let's do y equals 1 plus 2 times 4/3. All right, so this is going to get you 1 plus, multiply straight across is 1 plus 8 over 3. And then how can we add those numbers? Good, right? So make 1 over 1, and then you can do 3 over 3. So 3 plus 8, what does that get you? 11, right? So we get 11 over 3 as our y value for our second one. So that means our other answer is going to be 4/3 comma 11/3. So these are our two answers here. All right, kind of a bit of work. That's about as intense as these problems get. Sometimes there are other crazy cases, but this is about as complicated as we'll make it for this class. All right, and then we'll try one more. I think the next one's a little bit simpler than this one, so it should go by a little bit quicker. All right, do I need to be on this any longer? I think we got it. Okay. Okay, so let's try the same process with this one. All right, so let's get one of our variables by itself. Oh yeah, so yeah, your guys' is different. Just scribble out what's in your notes, replace it with this one. Okay, sorry about that. Anyway, which one looks simpler, the first one or the second one? The first one, right? So let's look at that first one. It looks like it's a little bit simpler, so let's try to get one of our variables by itself. What looks easier to get by itself? X or Y of the first one? Y. Definitely Y, right? So all we have to do to get that by itself, what do we do? Let's add the 2x. All right, and then we get for the second equation, y equals 5 plus 2x. All right, what do we do with that now? Yeah, right? Okay, right, so we're going to plug it into the second equation now. And then after we do that, we're going to get x squared minus, instead of y, it's going to be minus 5 plus 2x. And then plus 3x equals 1. And then we want to simplify as much as we can, so let's distribute that negative. We get x squared minus 5 minus 2x plus 3x equals 1. What combines here? Good, right? 2x plus 3x, or negative 2x plus 3x. So we get x squared plus x minus 5 equals 1. And then what do we always want these to equal? 0. So let's subtract 1 on both sides. And we should get x squared plus x minus 6 equals 0. And then we just factor it like normal, right? How is this one going to factor? Good, right? 3 and negative 2. So we get x plus 3, x minus 2. And then we get x equals negative 3 and x equals 2. So that means we're going to get two answers here. One of them is going to be negative 3 comma something. The other one is going to be 2 comma something. All right, so what do we do now to find those somethings? Plug it into what we originally substituted. So let's plug it into this with the y to find the y value. So I'm going to do that off to the side here. It's going to be 5 plus, let's start with x equals negative 3. So it's going to be 5 plus 2 times negative 3. So 5 minus 6, what does that get you? Negative 1. So this one's going to be negative 3 comma negative 1. And then when we do the same thing for x equals 2, we should get 5 plus 2 times 2. So 5 plus 4, which is 9, good. So 2 comma 9. So we get these as our two answers here. All right, good with those? All right, that's it for this lesson. Again, that's about as complicated as it gets, at least for this first lesson. Tomorrow we're going to do elimination. Should be pretty easy as well, and we're not really going to do ones like these. All right.